Section 334.20 of the National Electrical Code, or NEC, governs the installation of underground feeder, or OFF, cable within raceways. This section is crucial for understanding the rules when you decide to sleeve UF cable inside a conduit or other approved raceway. The primary purpose of using a raceway with UF cable is to provide additional physical protection to the cable, especially in areas where it may be susceptible to damage from impact, abrasion, or environmental factors. The NEC mandates that all electrical work complies with specific safety standards to ensure the protection of people and property. Therefore, understanding and adhering to Section 334.20 is paramount. When installing UF cable inside a raceway, the first consideration is the type of raceway being used. Common raceways include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMP, rigid polyvinyl chloride conduit, or PVC, and high-density polyethylene conduit, or HDPE. Each type has its own set of installation requirements and suitability for different environments. For example, RMC and INC are often used in areas where high mechanical strength is required, while PVC and HDPE are suitable for direct burial applications where corrosion resistance is important. The NEC requires that the raceway be properly sized for the number and size of conductors it will contain. This is to ensure adequate space for heat dissipation and to prevent damage to the conductors during installation. Table 1 in Chapter 9 of the NEC provides guidelines for conduit fill, specifying the maximum percentage of the raceway's cross-sectional area that can be occupied by conductors. When using UF cable, it is important to consider its overall dimensions, including the outer jacket. The fill calculations must account for the entire cable assembly, not just the individual conductors within. Another key consideration is the support and securing of the raceway. The NEC specifies the maximum intervals at which raceways must be supported to prevent sagging or displacement. These requirements vary depending on the type and size of the raceway. For example, PVC conduit generally requires more frequent support than RMC due to its low mechanical strength. In addition to physical protection, the raceway can also provide a degree of protection against moisture and other environmental factors. However, it is important to ensure that the raceway is properly sealed to prevent water from entering. The NEC requires the use of approved fittings and connectors for making connections to raceways and enclosures. These fittings must be suitable for the type of raceway being used and must provide a watertight or rain-tight seal as appropriate for the environment. When installing UF cable in a raceway, it is important to avoid damaging the cable during installation. The cable should be carefully pulled through the raceway to avoid kinking or abrasion. Lubricants can be used to reduce friction and make the pulling process easier. However, it is important to use lubricants that are specifically approved for use with electrical cables, as some lubricants can damage the cable insulation. The NEC also addresses the grounding and bonding of raceways. Metal raceways must be properly grounded to provide a path for fault current in the event of a short circuit. This helps to protect people and equipment from electrical shock. The grounding requirements vary depending on the type of raceway and the wiring system. Section 250 of the NEC provides detailed information on grounding and bonding requirements. When using PVC or other non-metallic raceways as separate equipment, grounding conductor must be installed within the raceway. This conductor provides a path for fault current and ensures that metal enclosures and equipment are properly grounded. The NEC also addresses the use of underground wiring. Section 300.5 of the NEC provides requirements for the minimum burial depth of underground cables and raceways. These requirements vary depending on the voltage of the wiring system and the type of location. For example, wiring installed under a driveway or parking area generally requires a greater burial depth than wiring installed in a grassy area. When installing UF cable underground, it is important to protect it from physical damage. This can be achieved by using a raceway or by burying the cable in a bed of sand or other suitable material. The NEC also requires that underground cables be marked to indicate their location. This can be done by burying a warning tape or marker above the cable. Another important consideration is the ampacity of the UF cable. The ampacity is the maximum current that a conductor can carry without exceeding its temperature rating. The NEC provides tables that specify the ampacity of different types of conductors under various conditions. When installing UF cable in a raceway, it is important to consider the directing factors that may apply. These factors account for the effects of ambient temperature, the number of conductors in the raceway, and other conditions that can affect the conductor's temperature. The NEC also addresses the use of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect wiring from overloads and short circuits. The size of the overcurrent protection device must be properly matched to the ampacity of the wiring. The NEC requires that overcurrent protection devices be readily accessible and properly labeled. In addition to the specific requirements for UF cable and raceways, the NEC also includes general requirements for all electrical installations. These requirements cover topics such as wiring methods, equipment installation, and safety procedures. It is important to be familiar with these general requirements as they apply to all electrical work. The NEC is a complex and comprehensive document. It is essential to consult the latest edition of the NEC and to seek the advice of a qualified electrical inspector or engineer when planning and executing electrical work. Compliance with the NEC is not only a legal requirement, but it is also essential for ensuring the safety of people and property. Section 334.20 specifically addresses situations where UF cable is installed within a raceway as a means of providing enhanced physical protection. This might be done in areas subject to mechanical damage or where the cable needs additional protection from environmental factors. The code emphasizes that the raceway must be suitable for the environment and installed according to its own specific requirement. For example, if using PVC conduit, it must be installed according to Article 352 of the NEC, which details the requirements for PVC conduit, including support, securement, and the types of fittings that can be used. Similarly, if using RMC, Article 344 governs its installation. When sleeving UF cable in a raceway, ensure the raceway's internal diameter is sufficient to accommodate the cable without causing damage during installation or hindering heat dissipation. The NEC provides guidelines on conduit fill in Chapter 9, Annex C, which should be consulted to determine the appropriate size of the raceway. The raceway must extend far enough to provide adequate protection. For underground installations, this might mean extending the raceway from below grade to a point where the cable is no longer susceptible to physical damage, such as where it enters a building or connects to other equipment. The NEC also requires that any exposed portions of the UF cable be protected from physical damage. This can be achieved by using a raceway or other approved means, such as a guard or shield. The NEC also addresses the use of UF cable in wet locations. UF cable is specifically designed for use in wet locations, but it is important to ensure that all connections and terminations are properly protected from moisture. The NEC requires the use of waterproof or rain-tight fittings and connectors in wet locations. It's important to highlight the significance of proper grounding and bonding when using metal raceways to sleeve UF cable. Grounding ensures a safe path for fault currents, minimizing the risk of electrical shock. The NEC provides detailed instructions on grounding and bonding requirements in Article 250. Always use approved connectors and fittings that are compatible with both the UF cable and the raceway material. This ensures a secure and reliable connection, preventing moisture ingress and potential electrical hazards. When transitioning from the raceway to free air, ensure the end of the raceway is properly sealed to prevent the ingress of water, dirt, or debris. Use appropriate sealing fittings or methods recommended by the raceway manufacturer. Always adhere to the manufacturer's instructions and recommendations for both the UF cable and the raceway system. This ensures proper installation and optimal performance of the electrical system. Before commencing any electrical work, it's crucial to verify the local electrical codes and regulations. Local amendments may exist that supersede or supplement the NEC requirements. Consulting with a qualified electrical inspector or engineer can help ensure compliance with all applicable codes and regulations. When installing UF cable in a raceway, consider the environmental conditions to which the installation will be exposed. Factors such as temperature extremes, exposure to sunlight, and the presence of corrosive substances can affect the performance and longevity of the cable and raceway. Select materials and installation methods that are appropriate for the specific environmental conditions. Regularly inspect the UF cable and raceway installation to identify any signs of damage or deterioration. Promptly address any issues to prevent potential electrical hazards or system failures. Document the UF cable and raceway installation, including details such as cable size, raceway type, and installation date. This information can be valuable for future maintenance and troubleshooting. When working with electricity, always prioritize safety. De-energize the circuit before commencing any work, use appropriate personal protective equipment, and follow safe work practices. The NEC provides comprehensive guidance on electrical safety in Article 110. Remember that the NEC is a living document that is updated regularly to reflect changes in technology and best practices. Stay informed about the latest edition of the NEC and any applicable amendments to ensure compliance with current codes and regulations. When installing UF cable in a raceway, consider the impact on the overall appearance of the installation. Choose materials and installation methods that are aesthetically pleasing and blend in with the surrounding environment. When installing UF cable in a raceway, consider the potential for future modifications or additions to the electrical system. Design the installation in a way that allows for easy access and modification, if needed. When installing UF cable in a raceway, consider the potential for electromagnetic interference, or EMI. EMI can disrupt the performance of sensitive electronic equipment. If EMI is a concern, use shielded raceways or other mitigation techniques. When installing UF cable in a raceway, consider the potential for rodent damage. Rodents can chew through electrical cables and raceways, causing damage and creating safety hazards. Use rodent-resistant materials and installation methods to protect the electrical system. When installing UF cable in a raceway, consider the potential for vandalism or theft. In areas where vandalism or theft is a concern, use tamper-resistant materials and installation methods to protect the electrical system. Always obtain the necessary permits and approvals before commencing any electrical work. This ensures that the installation meets all applicable codes and regulations. The NEC provides minimum standards for electrical safety. Always strive to exceed these standards to create a safe and reliable electrical system. Continuous learning and professional development are essential for staying up to date with the latest electrical codes, technologies, and best practices. Attend training courses, workshops, and conferences to expand your knowledge and skills. Share your knowledge and experience with others in the electrical industry. Mentoring and collaboration can help to improve the overall quality and safety of electrical work. The electrical industry plays a vital role in society. By adhering to the NEC and following safe work practices, you can help to ensure the reliable and safe delivery of electricity to homes, businesses, and communities. Firstly, understand the purpose of sleeving UF cable, which is primarily for physical protection. Secondly, choose the appropriate raceway material based on the environmental conditions and the level of protection required. Thirdly, ensure the raceway is properly sized to accommodate the UF cable without exceeding the allowable fill. Fourthly, install the raceway according to the NEC and the manufacturer's instructions. Fifthly, protect the UF cable from damage during installation by using appropriate lubricants and pulling techniques. Sixthly, properly ground and bond the raceway if it is made of metal. Seventhly, seal the ends of the raceway to prevent moisture ingress. Eighthly, inspect the installation regularly to identify any signs of damage or deterioration. Ninthly, document the installation for future reference. Tenthly, always prioritize safety and follow safe work practices when working with electricity. UF cable is designed for direct burial, but sleeving offers an extra layer of safety and protection. The NEC aims to standardize electrical practices for safety.